Mars has two moons, and they are named Fear and Dread. That is not a metaphor. In Greek myth, Phobos and Deimos were the two attendants who rode into battle beside the war god Ares, the god the Romans called Mars. So when astronomers found two tiny specks circling the red planet, they gave them the darkest names they could reach for, and it turned out to be strangely fitting, because one of these moons is doomed. Right now, as you watch this, it is falling, slowly, silently, spiraling toward the planet that will one day tear it apart. But the death spiral is not even the strangest thing about these two rocks. The strangest thing is that after nearly 150 years of studying them, nobody can agree on where they came from. And the answer to that question is about to fall out of the sky and into a laboratory. Stay with me, because this gets weird fast. Let's start with how we even found them, because that story sets the tone for everything that follows. It was August 1877, and an American astronomer named Asaph Hall was pointing the largest refracting telescope in the world, a 26-inch giant, at the U.S. Naval Observatory in Washington, at Mars. Mars was unusually close that year, a good time to hunt. But night after night, Hall found nothing. He got so frustrated he was ready to quit. According to the story that has followed the discovery ever since, it was his wife who told him to try one more night. He did. And that night, he caught a faint dot next to Mars. A few nights later, a second one. Two moons that had hidden from every telescope on Earth for centuries finally caught. Hall named them Phobos and Deimos, and a colleague suggested pulling those names straight from the Iliad, where fear and dread answer the war god's call. The bigger inner moon became Phobos, the smaller outer one, Deimos. And here's a detail that has haunted this discovery ever since, because it's one of the strangest coincidences in the history of science. 151 years before Hall found these moons, a writer described them. In 1726, the Irish satirist Jonathan Swift published Gulliver's Travels, and in the section where Gulliver visits a floating island of eccentric astronomers, Swift wrote that these fictional scientists had discovered two small moons orbiting Mars. Not one, not three, two. He even gave numbers for how far out they orbited and how fast they circled the planet. And when Hall finally found the real Phobos and Deimos, the actual figures landed in the same ballpark as Swift's invented ones. So did Swift somehow know? Almost certainly not. The likely explanation is a chain of educated guesswork that ran back to Kepler, who had reasoned that if Earth has one moon and Jupiter had several, then Mars, sitting in between, ought to have two. Swift was probably satirizing the science of his day, not predicting the future. But the guess was eerie enough that today, if you look at the little moon Deimos, one of the only two named features on its entire surface is a crater called Swift, named for the man who wrote them into a story before anyone had ever seen them. Now, when I say these moons are tiny, I want you to really feel how tiny. Our own moon is about 3,475 kilometers across. Phobos, the larger of the two Martian moons, is only about 27 kilometers at its widest point. Deimos is barely 15. You could line up more than 150 Phoboses across the face of the moon we see every night. They are so small that their own gravity is too weak to crush them into spheres, which is why they don't look like moons at all. They look like potatoes, lumpy, cratered, misshapen chunks of rock, and they are dark. Phobos is one of the least reflective objects in the entire solar system, bouncing back only about 7% of the sunlight that hits it. Darker than a lump of coal. That darkness is exactly why they stayed hidden for so long. And as you'll see, it's also one of the biggest clues to the mystery of where they came from. Hold on to that detail. It matters later. But before we get to the mystery, I want to take you to the surface of Mars and show you what the sky actually looks like from there, because it is genuinely alien. On Earth, we have one moon that rises in the east, drifts slowly across the sky over many hours, and sets in the west. Simple, predictable. Mars breaks all of those rules. Phobos orbits so close to Mars, just about 6,000 kilometers above the surface, closer than any other moon to any other planet in the solar system, that it whips around the entire planet in just 7 hours and 39 minutes. Think about that, a full orbit in less time than you spend asleep. And here is the truly strange part. Phobos circles Mars faster than Mars itself turns. So from the ground, Phobos appears to rise in the west, race across the sky, and set in the east, backwards. And it does this not once, but twice in a single Martian day, crossing the whole sky in about 4 hours, then coming back around to do it again. If you stood on Mars, you would watch a moon sprint the wrong way across your sky twice between sunrises. Deimos does the opposite. It orbits much farther out, around 23,000 kilometers, and it moves slowly, lagging behind the planet's rotation. So Deimos rises in the east and sets in the west, like our moon, except it creeps so gradually that more than 2 days pass between it rising and setting again. From the surface, it would look like little more than a bright moving star, so small that when it crosses in front of the sun, it appears as just a tiny black dot sliding across the disk. Even Phobos, the bigger one, can't fully cover the sun. When it passes in front, it blocks maybe a third of the solar disk and races across in 20 to 30 seconds, a strange, lopsided eclipse that NASA's rovers have photographed many times from the Martian ground. Perseverance once caught Phobos crossing the sun, and the resulting image looked so much like a giant staring eyeball that scientists joked about it. But those transit photos aren't just pretty. Every time a rover times one, it lets scientists measure the moon's orbit more precisely. And measuring Phobos's orbit is how we know it's dying. Because here is where the name Fear starts to earn itself. Phobos is not in a stable orbit. Every single century, it drifts about 2 meters closer to Mars. That sounds impossibly slow, and on a human timescale, it is nothing. But space runs on a different clock. This inward creep is relentless, and it never stops, and it never reverses. Phobos orbits so low and so fast that the tidal pull between it and Mars is stealing its orbital energy and dragging it down tighter and tighter, like water circling a drain. Scientists have run the numbers, and in somewhere between 30 and 50 million years, one of two things is going to happen to this moon, and both of them are violent. The first possibility is that Phobos simply slams into Mars, a 27-kilometer mountain of rock hitting the surface, carving out an enormous crater. But most scientists think the more likely ending is even more spectacular. As Phobos falls, it will eventually cross an invisible line called the Roche limit, the distance at which a planet's gravity becomes stronger than the moon's own ability to hold itself together. Once Phobos crosses that line, Mars will literally pull it apart, shattering it into a stream of rubble and dust. And that debris won't just fall straight down, it will spread out into a ring circling the planet. For a window of time, maybe a few million years, Mars will have rings, like a small temporary version of Saturn, before all that material eventually rains down onto the surface. The red planet, wearing a halo made from the corpse of its own moon. And the terrifying part, if you want to call it that, is that this process has visibly already begun. If you look at close-up images of Phobos, its surface is covered in long, strange, parallel grooves, like claw marks raked across the little world. For decades, scientists argued about what caused them. The obvious suspect was Phobos's biggest feature, a crater called Stickney, an impact scar nearly 9 kilometers wide, which is close to half the entire width of the moon. The collision that carved Stickney was so violent that it should have blown Phobos to pieces. It didn't, but it clearly rattled the whole body. The natural guess was that the grooves were cracks radiating out from that ancient impact. But newer analysis found something unsettling. Many of the grooves don't actually line up with the crater. Instead, they line up with the direction of Mars's pull. The leading interpretation now is that they are stretch marks, physical evidence that Mars is already stretching and deforming Phobos, that the moon has quite literally started to fail structurally, cracking under the strain of its own slow-motion destruction. Fear is coming apart at the seams, and we can see the seams splitting. So that's one moon falling to a violent end. And Deimos, its little sibling, is doing the exact opposite. While Phobos spirals inward toward destruction, Deimos is very slowly drifting away, edging outward over enormous spans of time, exactly the way our own moon is inching away from Earth. Give it long enough, and Deimos may eventually loosen from Mars's grip entirely and wander off into space, a moon that simply escapes. Two moons, born or gathered at the same planet, and yet fated to opposite ends. One devoured, one set free, which brings us, finally, to the biggest question of all, the one I promised you at the start. If Phobos and Deimos are so strange, so small, so unlike a proper moon, then where did they actually come from? And this is where 150 years of astronomy runs straight into a wall. For most of the 20th century, the answer seemed obvious. Look at these moons. They're small, they're lumpy, they're dark, and they're made of material that, from a distance, looks a lot like a certain class of asteroids, the dark, primitive, carbon-rich rocks that drift out beyond Mars. So the story went like this. Long ago, 2 asteroids wandered too close to Mars, and the planet's gravity reached out and grabbed them, capturing them into orbit, the way a fielder snatches a passing ball. 2 stray rocks, adopted by a planet. It's a clean, simple explanation, and it fit what the moons look like almost perfectly. For a long time, that was the textbook answer. But then people looked more carefully at how the moons actually move, and the simple story started to fall apart. Because here's the problem. When a planet captures a passing asteroid, that captured object should end up on a stretched out, tilted, eccentric orbit, coming in at a steep angle, looping around in a lopsided path. That's just how gravity capture works. But Phobos and Deimos don't do that. Both of them orbit in almost perfect circles, and both of them sit almost exactly over Mars's equator, neatly aligned, as if they belong there. That is not what captured asteroids are supposed to look like. That is what moons look like when they form right where they are, out of a flat disk of material spinning around the planet's middle. And that points to a completely different origin story. Not capture, but creation in place. In this second scenario, something enormous, an asteroid or a small protoplanet, smashed into the young Mars billions of years ago. The impact was so colossal that it blasted a huge amount of debris off both the impactor and Mars itself, flinging it into orbit where it spread out into a disk. And out of that ring of shattered rock, the material slowly clumped together and built up into Phobos and Deimos. If this is true, it's the same kind of story we tell about our own moon, which many scientists believe formed from the debris of a giant impact on the early Earth. Mars and its moons, shaped by the same catastrophe. So now you have 2 theories that flatly contradict each other. The moons look like captured asteroids, but they move like they were made in place. The composition points one way, the orbits point the other. And for years, that contradiction just sat there, unresolved. Recently, scientists have tried to thread the needle with clever hybrid ideas. One proposal from 2025 suggests something called disruptive partial capture, where an asteroid wandered in, got torn apart by Mars's gravity, and the shredded fragments then settled into a disk and reformed into moons, a scenario that is somehow both capture and formation in a disk at once. Another recent modeling study, published in 2025, ran detailed simulations of the moon's orbits and concluded firmly that whatever happened, these 2 were not simply grabbed as intact asteroids. But even the researchers admit there is still no way, from orbits and telescopes alone, to close the case for good. We have been staring at these moons for a century and a half, and we still cannot say for certain whether they are visitors from the asteroid belt or pieces of Mars itself. And that is not just a trivia question. It matters enormously, and here's why. If Phobos and Deimos formed from the debris of a giant impact, then they are made partly of ancient Martian material, frozen samples of what the young red planet was like billions of years ago, floating in orbit where we can reach them far more easily than the planet's own surface. But if they're captured asteroids, they are something almost more valuable in a different way. They would be pristine relics from the early solar system, the same kind of primitive, carbon-rich, water-bearing rock that may have helped deliver water and the raw ingredients of life to the young planets. Either answer rewrites a chapter of our history. The origin of these 2 moons is a lever that moves questions about how Mars formed, how the whole inner solar system came together, and how worlds get their water. That's an astonishing amount of meaning to hang on 2 lumps of rock smaller than most cities. So how do you finally settle a debate that telescopes have failed to resolve for 150 years? You stop looking from a distance and you go grab a piece. And that is exactly what is about to happen. Japan's space agency, JAXA, has built a mission called MMX, Martian Moons Exploration, and its entire purpose is to fly to Phobos, land on it, scoop up a sample, and carry that sample all the way back to Earth. The spacecraft arrived at its launch site in Japan in the spring of 2026 and is set to lift off late in the year during the narrow window that opens only once every 26 months when Mars and Earth line up. It will reach Mars in 2027, spend time orbiting and mapping both moons, then descend to the surface of Phobos around 2029 to collect its treasure. And landing on Phobos is its own kind of madness, because the gravity there is almost nothing. The little rover the mission carries, named Idafix, weighs about 25 kilograms on Earth. On the surface of Phobos, it would weigh the equivalent of about 15 grams, less than a slice of bread. The spacecraft can't even orbit these moons in the normal sense, because they're too small to hold anything in a proper orbit. So engineers had to design special looping trajectories just to hover nearby. The sampler will grab at least 10 grams of material, a scoop barely bigger than a spoonful, seal it in a capsule, and send it on the long journey home, with a planned arrival back on Earth around 2031, dropping into the Australian outback to be rushed to a clean laboratory near Tokyo. 10 grams. A single spoonful of dust from a moon named Fear could finally answer a question that has outlived the astronomer who discovered it, his telescope, and everyone who first argued about it. Because the moment scientists analyze that sample, they'll know. If it matches the composition of Mars, the giant impact story wins, and Phobos is a piece of the red planet flung into the sky. If it matches an asteroid, the capture story wins, and Phobos is an ancient wanderer that got trapped. And there's a beautiful twist buried in this. Even if the moons turn out to be captured asteroids, billions of years of Martian impacts would have sprayed material from the planet's surface up onto Phobos anyway. So that spoonful will almost certainly contain grains of Mars itself, which means MMX may end up being the very first mission ever to bring a piece of the Martian surface back to Earth, beating every sample return mission aimed at the planet directly. 2 moons named Fear and Dread, one tearing itself apart on its way down, one quietly slipping away into the dark. And after a century and a half of guessing, we are finally about to hold one of them in our hands and ask it the only question that ever mattered. Where do you come from? The answer is already on its way.